Okay, let's keep it going. So next page, let's find the measure of the missing angle. So we've got a missing angle this time, round to the nearest whole number. So whenever we're talking about a missing angle, we're going to be using our inverse functions of our sine, cosine, tangent. So let's just write down our functions once again. SOHCAHTOA. Okay, so everything's in relation to this angle here. So this angle here, I know my hypotenuse is across from the 90. Okay, now this is the adjacent side here. So we can see that we're going to be using a cosine function of that missing angle. So the cosine of that missing angle, okay, is going to be the adjacent 13 over the hypotenuse 18. But if we're doing that, realize we're looking for a missing angle. So we're using our inverse function. Inverse. Our inverse functions. So we're going to be using an inverse cosine. So that missing angle is going to be the inverse cosine of that 13 over 18. So we're going to round this to the nearest whole number. So let's put that in our calculator. So inverse cosine, so let's clear that out. So inverse, so second cosine, okay, second cosine, and 13 divided by 18, 13 over 18, in which case we get approximately 43.76, but if we're going to round that to the nearest whole number, it's going to round up to the 7 is going to round that 3 up to a 4, so approximately 44 degrees. Okay. Take a look at the bottom one here, number 7. So what type of triangle is triangle ABC? Select all that apply. Well, we have a few different options. We have equilateral, right, isosceles, scalene. So we have to remember what these mean just for our vocabulary here. Now, equilateral would mean all sides the same. Okay, all sides the same. A right triangle would be a triangle that has a 90-degree angle somewhere in the triangle. Isosceles tells us that there's going to be two sides or two angles congruent. And scalene, well, that's going to tell us that all three sides have some different lengths. So all sides different. Okay, so if we're trying to figure this out, well, let's just take a look at the different sides of our triangle. Like, for instance, if I've got AB here. Now, AB is a diagonal of this right triangle that you can draw here. Okay, and we can see that it's a 1/3 triangle. So using our Pythagorean theorem, we can say that AB is going to be the square root of a 1 squared plus 3 squared. Or in other words, in this particular case, this is a square root of 1 squared is a 1, 3 squared is a 9, 1 plus 9 is 10. Okay, so if we have that one, let's take a look at BC. Well, BC is this segment here, and once again, we can make a right triangle where BC is the diagonal of that right triangle. And we can see that it's 1/3 again. It's just in a slightly different order. So BC is also a 1 squared plus a 3 squared. Take the square root of that. We're still going to get the square root of 10. Now notice we've got two sides that are congruent already. Square root of 10 and square root of 10. So we know it's not going to be scalene because already two sides are the same. This would be all sides different, so it's not going to be scalene. So it's either going to be equilateral or isosceles. So for equilateral, all sides would be the same, so we have to figure out this side over here, AC. Now we have a pretty good feeling about AC. We can see that it's actually, well, it's a bigger triangle. This AC is a diagonal that is a larger diagonal, makes a larger triangle here. So just to confirm here, AC is a 1, 2, 3, 4 by 2. 4 squared plus 2 squared. And we can see we got different numbers. This is going to be a different number as well. Well, 4 squared is 16. 2 squared is a 4. 16 plus 4 is a 20. So square root of 20. So we know it's not equilateral. Okay, so two sides are congruent. It's going to be isosceles. Okay, so we know it's going to be C there, but now, is it a right triangle? Okay, so how can we prove something's a right triangle? Well, we're going to take a look at the angles, or in other words, the slopes of the different sides. Now, if we're looking at this triangle ABC, where does it look like our right triangle resides? Our right angle resides. It looks like it probably lives over here, right there in that corner between AB and BC. Now, remember, for our right angles, we should see perpendicular. We're going to have two slopes that are opposite reciprocals of each other. So let's figure out our slopes for the different ones, AB and BC. So our slope of AB, okay, is rise over run. So from A to B, I'm rising by 3. 1, 2, 3, running by 1. 3 over 1. And the slope of BC, okay, I'd be going down 1 and then over 3. So down 1 over 3. And what do you notice about these two? These are opposite signs, positive, negative, and reciprocals. 3 over 1, 1 over 3. Okay? So therefore, we're going to know that BC is perpendicular to AB. And if we're perpendicular, that means that there's a right angle. There is definitely a right angle. Where BC and AB meet. So that's why we have a right isosceles triangle.